Good day, friends. CEV Group welcomes you for watching this video. Please do not forget to like, comment, and subscribe our YouTube channel, Registered Values Club, for getting all new professional updates. In this video, we will discuss about quantity surveying in civil engineering. So this is an important topic for engineers as well as architects. So who are in the building line, and even in valuation field this is an important topic. So please watch this video till the end, because in the last few slides we will discuss about center line method of estimating, which is very important method, and which as a valuer, which as an engineer or as an architect you have to be conversant with. So we will discuss that method in the last few slides. So first of all, we will discuss what is quantity surveying in engineering. A comprehensive exploration of cost estimation, measurement, and financial management in building construction, with the practical application in Indian contexts. We will discuss about this in this presentation. So, what is quantity surveying, and what is the role of a professional in quantity surveying? As far as quantity surveying is concerned, it is a specialized discipline within civil engineering focused on managing all aspects of contractual and financial side of construction projects. Quantity surveyors are the financial backbone of construction, responsible for estimating, cost planning, procurement, advice, and contract administration. They work from initial feasibility study through project completion, ensuring that construction projects are delivered within budget while maintaining quality standards. So, in the Indian context, quantity surveyors play a crucial role in both public works under organizations like CPWD and private construction projects. They must be familiar with the various standards, specifications, including IS codes, PWD schedules of rates, and regional building bylaws that govern construction practices across India. So now we will discuss what are the core responsibilities of a quantity surveyor. First of all, the first responsibility is cost estimation. They prepare detailed estimate for projects based upon drawings and specifications. And then they have to prepare bill preparation. So creating bills of quantity, which is also called BOQ, for tendering purposes. Then, as a valuer, for measuring completed works and certifying payment to the contractors. And they have to work in the field of cost control. So, monitoring project expenditures against budget throughout the construction is the responsibility of quantity surveyor. Then, contract management, administrating contracts and resolving disputes. And finally, they have to prepare final statements and settling contractors' claims. As far as quantity survey in Indian construction context is concerned, India presents unique challenges and opportunities for quantity surveying. The region's diverse climate, from extreme heat of summers to cold winter influences material selection and construction methodology. Building practices must account for seismic consideration as much of the North India falls in moderate to high seismic zones. Traditional materials like brick masonry remains prevalent alongside with the RCC construction. Local labor availability, skill levels and wage rates significantly impact cost estimation. Understanding regional variations in material cost, transportation challenges, and seasonal constructional practice and patterns is essential for accurate quantity surveying in this context. So, first of all, before proceeding, will discuss about the different building components. So, there are three things mainly involved in building construction. First thing is substructure, second part is superstructure, and third thing is finishes. Substructure is the foundations and below ground elements that transfer building loads to the soil. That part is called substructure. It includes earthwork excavation, foundation systems, basement constructions, and plinth protection. And the second part of the building is superstructure. The part above ground structural elements forming building envelope is called superstructure. So the load bearing walls, RCC frames and slabs, beams and columns, roof structures, etc. They comes under the heading of superstructures. And then finishes. Finishes means architectural and aesthetic elements completing the building. It includes plastering and painting, flooring systems, doors and windows, and of course fixtures and fastenings. In this part of the presentation, we will only confine ourselves to substructure estimation. So here understanding the foundation and below ground construction components that form the critical base of any building project. So we will deal with the different co- components in different presentations. In this presentation, we will confine ourselves to substructure estimation only. So, as we have already discussed, we know we will discuss in details the different components of substructure works. The first work is site clearance and preparation. Site clearance and preparation is removal of vegetation, demolition of existing structures, and leveling of construction site to create a clean work platform. It is called site clearance and preparation. Then comes excavation works, digging of foundation trenches, basements, and other below ground spaces to required depths and dimensions is called excavation works. Next part is foundation construction, building the load bearing base, including footings, beams, rafts, or pile foundation as per structural design. Next part is damp proofing treatment, application of protective layers to prevent moisture ingress from ground into building structure, that is called damp proofing treatment. Then plinth beam and protection, construction of tie beams at ground level and protective measures around the building perimeter. And the next part or the last part is backfilling and compaction, refilling of excavated areas with suitable material and compacting it to achieve required density. So first part, now we will discuss all these things in details. First thing you know is site clearance and preparation. First, we will discuss how this work is measured. What is measurement methodology in style, site clearance, and preparation? So, site clearance is measured in square meters and involves removing all obstacles from the construction area. This includes cutting and removing trees, shrubs, and grass, demolishing existing structures, removing topsoil containing organic matter to a depth of 150 to 200 millimeter, and disposing of the debris off-site. Especially in North India, many urban sites contain old structures requiring careful demolition, while rural sites may have significant vegetation. So, what are the measurement rules for site clearance and preparation? Measure the total plot area, including the construction footprint plus working space. So, working space is generally 1.5 meter all around. Then, topsoil removal is measured separately from clearing vegetation. Then, disposal distance also affect the cost. It is typically measured up to 50 meter as standard, and any salvageable material such as bricks, timber, stones, they are noted separately. So now we will take an example that will make the things clear. For a residential area building with a built-up area of 200 square meter, the clearance area would be calculated as building length plus 3 meter plus building width into 3 meter. If the building is 20 meter by 10 meter, clearance area will be 23 meter by 13 meter, means 299 square meter. So let us suppose the rate per square meter for clearance is 45 rupees per square meter. So the site clearance cost would be approximately 299 multiplied by 45 rupees 13,455. Second, you know, is excavation in foundation. So what is excavation in foundation? We have already discussed. Here we will discuss in detail how it is measured and how the cost of excavation for foundation is calculated. Excavation is one of the most critical and cost intensive activities in substructural work. It involves removing earth to a specified depths and dimensions to accommodate foundations, basements, and underground services. The quantity of excavation directly impacts the project cost through labor, equipment, and disposal requirements. Accurate measurements ensure proper budgeting for this essential activity. So, well, first of all, we will discuss about the different types of excavation in building construction. So, it depends upon the type of soil. So, there are different types of soils: ordinary soil, hard soil, soft artist integrated rock, or hard rock. So if the excavation in ordinary soil, so most common type in Indian plains involves loose to medium dense soil that can be excavated with the manual tools or light machinery. So typical in alluvial plains of Punjab, Haryana, and UP, and its rate varies from 180 rupees to 250 rupees per cubic meter depending upon the depth. Then excavation in hard soil or gravel, it involves compact soil mixed with gravel or conchers, which is generally calcium carbonate nodules. These are common in Delhi NCR area and Rajasthan. It requires mechanical excavation equipment and may need water sprinkling, so it will be having some higher rate than the excavation in ordinary soil, and this rate varies from rupees 280 to 350 per cubic depending upon the depth. Next is excavation in soft or disintegrated rock. These are generally found in hilly terrains and certain parts of Rajasthan and Uttarakhand. Rock can be broken with picks and crowbars, so it requires skilled labor and more time, and hence it will be having higher rate, and its rate varies from rupees 450 to rupees 600 per cubic meter. Next is excavation in hard rock. Solid rock requiring blast or rock breakers. So less common in building construction but may be encountered in hill stations like Shimla to Missouri, and its rate varies from 800 to rupees 1200 per cubic meter, including controlled blasting. Next is how the excavation is measured. So now we will discuss about excavation measurements, especially foundation trenches. The calculation methodology of excavation measurement involves foundation trench excavation is measured in cubic meter. The quantity depends on foundation width, depth, and total depth of walls. For a typical Indian residential building with load bearing walls, foundation trenches are usually 900 to 1200 millimeter wide and 1200 to 1800 millimeter deep, depending upon the soil bearing capacity. So, measuring formula volume is equals to length into width into depth. So, what some important consideration we should taken into consideration we should take care about is excavation depth is measured from natural ground level to formation level. Working space of 300 millimeter is added on each side of the form work for construction convenience, but it is to be seen whether it is available on all the sides or not. Then corners or junctions are measured only once to avoid duplication. So we will discuss it in details when we will be dealing with the center line method, how it is done. Then stepped excavation in sloping sites is made separately for each level, and disposal of excavated earth up to 50 meter is included. Beyond this is measured separately. So now we will be taking an example. Let us say we are having a two-story residential building, load-bearing brick walls. External wall length is 60 meter total perimeter. So we will discuss it in detail how this perimeter is calculated while will be doing a center line method. So please watch this video till the end. So yes, all the things are clear. Then let us suppose external wall length is 60 meter total perimeter, internal wall length is 35 meter, and foundation width is 1000 millimeters means 1 meter, excavation depth is 1500 millimeter means 1.5 meter, and working space, let us suppose we are having a working space 300 millimeter on each side. So effective excavation width will be it is 1 meter and 0.3 meter on both sides, so it will be 1 plus zero point 0.3 plus zero point 0.3 1.6 meter. Total length 60 meter plus 35 meter. External walls plus internal walls, total length is 95 meter. So volume will be 95 meter into 1.6 into length depth, which is 1.5 meter. It is given a excavation depth, so it is 228 cubic meter. So let us suppose the rate is 220 rupees per cubic meter. So 228 into 220, it is rupees 50,160. This is how foundation trenches excavation is measured and the cost of excavation is calculated. For details, please remain and watch this video till the end. There will in the last few slides we will discuss how this perimeter of external and internal walls is calculated and how the corners and junctions are made only once to avoid duplication. we will discuss it in center line method. So this is a detailed diagram how this diagram illustrates typical foundation trenches cross section showing a relationship between foundation width, working space and excavation depth. Key elements includes natural ground level at the top, working space of 300 mm on both sides, foundation depth 900 to 1200 mm depending upon the wall thickness and load, excavation depth 1200 to 1800 to reach suitable bearing strata, foundation concrete or brickwork at the bottom, and the formation level where foundation will be laid. The sides of excavation should be vertical or slightly battered for stability. In loose soils, temporary shoring or benching may be required, which adds to the cost and must be included in the estimates. And then this was for the excavation of strip footing, which are generally used for load bearing walls. And if you are excavating for columns, and then for columns, if we are providing isolated footings, then how the foundation for isolated footings are measured and how its cost is calculated. So for RCC frame structures, footing may be isolated footing, it may be combined footing, it may be raft footing. Here we are discuss about the isolated footing. So in modern construction using RCC framed structures, loads are transferred through columns to the isolated footings. Each footing requires a separate pit excavation. The size of footing depends upon the column load and soil bearing capacity. So its size typically ranges from 1.5 meter by 1.5 meters to 3.3 meter by 3 meter for residential buildings in most of the parts of India. So how it is measured? Each footing pit is measured individually and then multiplied by the total number of footings. Working space of 300 to 600 millimeter is provided all around the formwork installation and construction access. For example, we are having footing size of 2 meter by 2 meter, depth of the footing is zero point 0.5 meter, depth of excavation is 2 meter from the natural ground level, working space 0.5 meter all around, and number of footings is 16. So excavation size per pit will be 2 meter plus zero point 0.5 meter on both sides, means 2 meter plus 1 meter, 2 meter plus 1 meter, and multiplied by 2 meter. So total excavation will be 18 cubic meter. So depth of excavation is 2 meter, it is given, and total excavation there are 60 number of footings. So for one footing it is 18 cubic meter, and for 16 uh, columns footings it will be 18 into 16, 288 cubic meter, and cost at 2 rupees 240 rupees per cubic meter will be 288 multiplied by 240, it will be rupees 69,120. So generally in areas like in Delhi NCR where soil bearing capacity is generally 150 to 200 kilonewton per square meter, footing sizes for typical residential buildings G plus 2 to G plus 4 range from 1.8 meter to 2 1.18 while into 1.8 to 2.5 to 2.5 meter. The water table in many parts of India is high 3 to 5 meter below ground level, requiring dewatering during excavation, which adds approximately 800 to 1200 per footing of the cost. So next is anti-termite treatment. So there first we will discuss about pre-construction treatment. It is applied to the soil before laying foundation concrete. Chemical emulsion is sprayed at 5 liter per square meter on the bottom and sides of the excavation. It is essentially in North India where termite infestation is common, especially in area with high moisture content. Treatment projects in the buildings for 5 to 7 years. So around plinth area, after backfilling and before laying footing, flooring, another layer of treatment is applied at the plinth level. This creates a chemical barrier preventing termites from entering the building through the floor. It is particularly important for ground floor constructions and areas with direct earth contact. So there are two type of anti-treatment treatments, anti-termite treatment. First is pre-construction treatment, which is provided in the plinth part, in the foundation part, and after it is constructed up to plinth level. Then around the plinth area, after backfilling and before the laying of flooring, another layer of treatment is applied at the plinth level. How this anti-treatment termite treatment is made and cost is calculated. Anti-termite treatment is measured in square meter of the area treated. For a building with a 200 square meter footprint, the treatment area includes the entire foundation area plus 300 millimeter strip around the perimeter. So total area will be 200 plus perimeter into 0.3 and approximately 225 square meter. Cost is rupees 45 to 60 rupees per square meter using approved chemicals like chloropyrifos or other any other types such as bifenthrin. Total cost will be rupees 225 into 45 rupees 10,125 to rupees 13,500. So this include chemical cost, labor for mixing and spraying, and equipment charges, etc. Then foundation concrete. It is also called PCC, plain cement concrete. Plain cement concrete means no reinforcement is provided. It is provided at the formation level at the bottom of the foundation. So plain cement concrete is laid at the bottom of a foundation trenches to create a level, clean surface for foundation construction. It prevents direct contact between foundation and the soil, reduces cement leaching and ensures uniform load distribution. So the function of PCC is to reduce cement leaching and ensuring uniform load distribution. So standard mix which is used is 1 is to 4 is to 8 cement, sand and aggregate or M10 grade, and its typical thickness is 100 to 150 millimeter, means 4 to 6 inches. So how this PCC is made? It is made in cubic meter. The volume is calculated as the area of the foundation length into width multiplied by the thickness. For example, total thick length of the wall is 95 meter, as we have already discussed in the previous slides. Foundation width is 1 meter. Let us suppose the PCC thickness is 0.15 meter, means 150 millimeter. So volume will be 95 into 1 into 0.15, 14.25 cubic meter. So rate analysis, cement approximately for 1 cubic meter 4.5 bags will be used, and assuming the rate to be 400, so cost of cement will be 1800. Sand 0.45 cubic meter at the rate of 1400 rupees per square meter per cubic meter, 6 rupees 630, and aggregated 40 millimeter approximately zero point 0.9 cubic meter at the rate of 1600. So total cost will be of aggregate will be 1440. So labor for mixing and laying, let us suppose it is 850, and work charges and miscellaneous is 180. And if you calculate all this these costs, the total rate comes out to be rupees 4900 per cubic meter. So volume is 14.25 cubic meter and rate is 4900 per cubic meter. So the cost will be approximately 69,825. Then foundation construction. So in India, brick masonry foundations remains popular for load-bearing structures and low-rise buildings due to cost effectiveness and local availability of material. First class brick conforming to IS 1077 are laid in cement mortar, typically in English bond for maximum strength. Foundation walls are usually 450 millimeter, means 18 inches thick for the outer walls, and 230 millimeter, means 9 inches for inner walls. The masonry rises from PCC levels to plinth level, creating a stable base for the superstructure construction. So brick masonry construction, how they are made and how the rate is calculated. Brick masonry in foundation is measured in cubic meters. The volume is calculated as length into thickness into height. Standard brick size in India is 230 millimeter by 115 millimeter by 75 millimeter with 10 millimeter mortar joints. It becomes 240 millimeter by 120 millimeter by 80 millimeter modular size. So, what are the key measurement points in brick masonry foundation? Measure length on the center line for the walls. How it will be done, we will discuss in the center line method. Deduct opening, if any, rare in foundation. Include projections like offsets. Measure stepped foundations separately. Note mortar mix ratio, it is typically 1 is to 6 to 1 is to 5. So you must remember materials quantities required per cubic meter for foundation. First color bricks is 500 numbers. Cement 1.6 wax means 80 kg for 1 is to 6 mortar. Sand is 0.30 cubic meter and water 150 to 200 liters. For example, let us suppose we are having external walls 450 millimeter thick, 60 meter length, internal walls 230 millimeter thick, 35 meter length, foundation height let us suppose is 1.2 meter. So external wall masonry is 60 into 0.45 multiplied by 1.2 meter is foundation height 32.4 cubic meter, and internal wall masonry 35 into 0.23 into 1.2 9.66 cubic meter. Total masonry is 42.06 cubic meter. So you can calculate the quantities as per these requirements. Bricks 500 at the rate of 6.5 per cubic meter, 33,250. Cement 1.6 pack at the rate of 400 rupees 4 640. Sand 0.30 cubic meter at 14,000 per cubic meter rupees 420. Mason labor, let us suppose it is 850 per cubic meter. Helper labor is 550 rupees per cubic meter, and water and miscellaneous charges let us suppose is 140 rupees. So total it comes out to be 5850 per cubic meter. So 42.06 multiplied by 5850, the cost becomes 2,46,051. Foundation masonry. So if you see the detailed cross sections which shows the complete foundation assembly from bottom to top, natural ground level, it forms the reference point for all measurements. Excavation and extends from 1200 to 1800 millimeter below ground level to reach firm bearing strata. So you know the depth of the foundation is generally it is not that you have to go up to 1.2 meter or 1.8 meter. You have to go up to hard strata. Maybe it may be available at 1 meter, it may be available at 2 meter, it may be available at 3 meter, 4 meter, or 5 meters. You have to excavate up to the level where you get hard strata. Then PCC bed, its thickness is 150 to 100 to 150 millimeter, which provides clean level base. Foundation masonry generally provided in 1.5 1 is to 5 to 1 is to 6. It rises from PCC to plinth level. Typically, its height 900 to 1200 millimeter. So offsets or footings provide wider base for load distribution, usually in the steps of 75 millimeter projections. Then damp proofing course at the plinth level prevents moisture rise. Plinth levels set 450 to 600 millimeter above ground level for a flood protection. The foundation width tapers from 600 to 900 millimeter at the bottom to the wall thickness 230 to 450 millimeter at the plinth level through brick offsets. This traditional design, proven over centuries, remains cost effective for buildings up to 3 stories in generally in North Indian construction. Next is RCC foundation. So now we will discuss about the isolated footings, how they are calculated. So first, what is the purpose of providing isolated footing. For RCC framed structure, isolated footings are most common foundation type. Each column transfer its load through the square or rectangular footing to the soil. The footing is designed as a reinforced concrete slab that distributes the concentrated column load over a larger area, ensuring bearing capacity is not exceeded. So basically, the function of foundation is to distribute the load of the column or load of the wall to a wider area so that the stresses are within permissible limit. The load is distributed over a larger area, and that soil bearing capacity is not exceeded. So what are the components of the footing, isolated footing? We are having PCC base 100 millimeter thick. Let us suppose for M10 grade, main footing 400 to 600 millimeter thick. See here, 400 to 300, 600 millimeter thick. M20 or M25 grade of RCC. Column started bars projecting from the footings for the column connection. Main reinforcement we provide, let us provide 500 millimeter, 500 FE 500 bars in both directions at the bottom. How it is measured? Footings are measured individually in cubic meters for concrete and in kilograms for steel reinforcement. Each footing is calculated separately, then multiplied by total number of footings. Let us suppose that the footing size is 2 meter by 2 meter by zero point 0.5 meter thick. So concrete volume per footing will be 2 by 2 into zero point 0.5. 2 cubic meter number of footings, let us suppose, is 16. So total concrete will be 2 into 16, 32 cubic meter. Then how the reinforcement is estimated for a 2 meter by 2 meter footing? So main bars, let us suppose, are 16 millimeter dia at a 150 millimeter center to center bars in each directions. So 16 diameter at 150 millimeter center to center. So 2000 multiplied by 150. See, see here, you have to divide 2000 divided by 150. So there will be 40 number of length per bar. So length, there will be bars in each direction will be 14 numbers. So length of the bar will be 2 meter plus 1 meter anchorage 2.1 meter. So total bars will be 14 numbers in each direction. 14 plus 14, 28 bars. Weight per meter for 16 millimeter bar. So for that, you know the formula is d square upon 162. D square is 16 square divided by 162. It is 1.58 kg per meter. So total steel required per footing will be 28 number of bars of length 2.1 meter and weight per meter is 1.58. So total steel required will be 93 kg per footing for 16 footings. 16 into 93, 1488 kg total. The steel rate varies from 65 to 75, including cutting, bending and binding. So you can, in this way you can calculate the cost of reinforcement in the foundation part. So RCC footing, how the rate is found out. Now we will discuss about the rate analysis of RCC footing. For concrete work, for M20 grade RCC per cubic meter, cement for M20 grade is cement per cubic requirement is 7.5 bags at 400 rupees per bag, rupees 3000. Sand 0.42 cubic meter at 1400 rupees per cubic meter, rupees 588. Aggregate 20 millimeter 0.84 cubic meter at the rate of 6000, 1650 to 1386. Labor mixing, laying, compacting, etc. rupees 1850. Shuttering work, form work rupees 450 per cubic meter. Water and miscellaneous charges, let us suppose it is 226. Total 7500 per cubic meter. So as we have calculated 32 cubic meters, so the concrete work will be 32 into 7500 rupees 2,40,000. Steel requirement rate per kg is approximately 52 rupees per kg. Cutting and bending, let us suppose it is 6 rupees per kg. Binding wire 2% of steel, rupees 2 per kg. Labor for fixing 8 rupees per kg. Wastage 2.5%, 1.5 rupees per kg. So total cost comes out to be 69.5 rupees per kg. So for 1488 kg, cost is 1,03,460. And total cost, footing cost will be PCC base. You have calculated FRM 28,800, RCC concrete 32 lakh 42,000 to 32, sorry, 2 lakh 40,000, and steel reinforcement is 1 lakh 3,416. Excavation we have already calculated. So include all these things, it is 3,72,216, and there are 16 number of footings, so the cost per footing will be 23,264. Next is dam proofing course. Dam proof course. Dam proof course is a critical waterproofing layer which is installed at plinth level to prevent moisture from rising through capillary action from ground into walls. It is especially in northern India where monsoon rains are heavy and winter fog creates a ground moisture. DPC is essential for building durability and preventing dampness related issues like paint peeling, plaster deterioration, and unhealthy indoor conditions. DPC materials and applications, and how it is applied and how its cost is calculated. Now we will discuss it in this slide. Common DPC materials in India: cement concrete with the waterproofing compound, most economical and is widely used. A 40 millimeter thick layer of 1 is to 2 is to 4 cement concrete is mixed with 2% integral waterproofing compound like Dr. Fixit, Force Stroke or ACC waterproofing. This creates a dense impermeable barrier. Next type is bituminous asphalt DPC. Two coats of hot bitumen melted to 150 to 160 degrees centigrade is applied on a masonry surface, creating a continuous waterproof membrane. Effective but messy and requires skill application, which is common in public works. Then membrane DPC. It is preformed sheets of bitumen, felt or polymer modified materials laid over masonry. More expensive but easier to apply and very effective. Brands like Buildmate, Derby Gum are used in premium construction. And then you may be using chemical DPC. It is constructed with liquid chemicals brushed onto the masonry or mixed with mortar. Newer technology gaining popularly in urban India for renovation works. So, how this DPC is measured and how its cost is calculated. DPC is measured in square meter, covering the entire width of the wall at the plinth level. For example, let us suppose a building perimeter is 70 meter, external wall thickness is 0.23 meter, internal walls are 40 meter by 1.115 meter. So area will be 70 into 0.23 and 40 into 0.115. So only remember only these two dimensions are to be taken into calculation. So total will be 16.1 plus 4.6, 20.7 square meter. So let us suppose we are having CC with waterproofing, 40 millimeters CC with waterproofing. So concrete 1 is to 2 is to 4, 80 rupees per square meter. Waterproofing compound 45 rupees per square meter. Let us suppose labor is 65 rupees per square meter. So total 180 plus 45 plus 65 rupees 290 per square meter. Area is 20.7 square meter into rupees 292, sorry, 290 rupees 6003. For bitumen DPC, rate is approximately 180 to 220 per square meter, including material and labor. Next is plinth protection. So plinth protection, what is plinth protection and how it is measured and how its cost is calculated. Plinth protection is a sloped concrete apron constructed around the building perimeter, typically 600 mm to 900 mm wide and 75 to 100 mm thick. It directs the rainwater away from the foundation, preventing soil erosion near the walls and water seepage. The surface slopes outward 1 is to 20 gradients. See here. So after backfilling is complete, the earth is excavated up to 100 millimeter depth for the protection width. A 50 millimeter sand bed is laid and compacted, then 50 to 70 millimeter thick cement concrete 1 is to 3 is to 6 is laid with outward slopes. Expansion joints at 3-meter intervals prevent cracking. Surface may be finished with tiles or left plain. Hello, हाँ जी, ਨਾ 2 ਘੰਟੇ ਠਹਿਰ ਜਾ 2 ਮਿੰਟ ਮੈਂ ਥੱਲੇ ਸੀਗਾ ਨਾ ਨਾ ਮੈਂ ਤਾਂ ਉਹ ਕਰਦਾ ਪਿਆ ਸੀਗਾ ਦੂਜੀ ਬਣਾਉਂਦਾ ਪਿਆ ਸੀਗਾ ਵੀਡੀਓ ਆਹੋ how it is designed. Plinth protection is a sloped concrete apron which is constructed around the building perimeter. It is typically 600 to 900 mm wide and 75 to 100 millimeter thick. It uh, directs the rainwater away from the foundation, preventing the soil erosion near the walls and prevent water seepage, etc. The surface slopes outward at 1 is to 20 gradient. So its construction method is after backfilling is complete, the earth is excavated to a 100 millimeter depth for the protection width. A 50 millimeter sand bed is laid and compacted. Then 50 to 75 millimeter thick cement concrete 1 is to 3 is to 6 is mix is laid with an outward slope of 1 is to 20. Expansion joints at 3-meter intervals prevent cracking. Surface may be finished with tiles or left plane. How it is measured and what is its cost? It is measured in square meter of covered area for a building with 70 millimeter perimeter and 0.75 meter protection width. So the protection area will be 70 into 0.75 means 52.5 square meter. Cost breakdown is sand bed 50 millimeter rupees 20 per square meter, concrete 75 millimeter thick at the rate of 185 rupees per square meter, and let us suppose the labor rate is 80 per square meter. Total per square meter rate comes out to be 290 per square meter. So for 52.5 square meter the amount will be 115,225. And if the tile finish is provided, which is common in northern India urban homes, it adds to 220 to 350 per square meter for tiles for fixing, bringing the total to 510 to 640 per square meter. So next step is backfilling and earthwork. So what is backfilling? What is its process? After foundation construction and plinth protection are complete, the excavated areas around the foundation must be refilled with the soil and properly compacted. This restores ground levels and provides lateral support to the foundation walls. For backfilling, the material generally used is excavated soil which is free from organic matter, roots, or debris. In India, often a mix of local soil with the sand for better drainage is used. So it is compacted in layers of 150 to 200 millimeter. So each layer is watered and compacted using mechanical rammers or plate compactors to achieve 95% maximum dry density. It is done as per IS 272 Euro soil testing IS 94451. Earthwork and road construction are applicable for the compaction, but it is measured in volume of excavation minus volume occupied by foundation and plinth. So let us suppose as we have done now, total excavation is 228 cubic meter, foundation volume is 42 cubic meter. So the fill required will be 228 minus 42 186 cubic meter. The rate is 120 rupees per cubic meter including compaction. So the cost comes out to be rupees 222,320. Then there are different methods of calculating the quantities of material. There, then this CBRI Roorkee Central Board of Central Building Research Institute Roorkee, it has given certain equations for calculating the materials. So see here for calculating number of bricks in 100, the equation for single story is 2.26 into a plus 6 is 6.8, where a is plinth area in square meter. So these are the equations which are given for different types of structures. For by using these equations you can calculate the required quantities of materials required, and then they have also given equations for calculating the labor for superstructure only. Plinth area in square meter, labor the masons, carpenter, blacksmith, mazdoor. So these are the equations for single story 1.335 a plus 28, for double story 1.335 into a plus 26, and four story building superstructure RCC framed 1.67 a minus 2. So these are the equations given by CBRI. By using these equations you can calculate the material and labor required. Then another method which is very accurate method for estimating the quantities of material is detailed cost method. This is very accurate type of estimate. Quantities of items in this method are measured and cost of each item is of work is calculated separately. The rates of different items are provided according to the current schedule of rates, and the total estimated cost is calculated at 3 to 5% of estimated cost, which is added to this for contingencies as miscellaneous expenditure. The detailed estimate should be consisting of the following details and documents: report, general specification, detailed specifications, drawing plans, layout plans, elevation, sectional view, detailed drawings, etc. Design and calculation in case of building, design of foundation, beams, slabs, etc. And of course, schedule of rates. So there are two methods of detailed cost estimate. One is long wall and short wall method, and second method is center line method. So as we have already discussed at the start, that we will be discussing central line method in detail. So first of all, we will discuss how the center line length is calculated. Let us suppose you have a room with external dimensions as 3600 millimeter by 3600 millimeter as shown in the figure, and all the walls are 300 millimeter thick. So for calculating center line, total external perimeter is 4 into 3600 means 1000, 14,400. So for center line you will be having, you draw a center line means at 150 millimeter on this side and 150 millimeter on this side. So the length which is 3600, so center line length will be 3600 minus 150 minus 150, 150 on both the sides, so it will be 3300. So all the walls will be 3300 millimeter. So the center line length will be 4 into 3600 minus 150 minus 150, 13,200. So see here, actual external perimeter is 14,400 and total center line length is 13,200. So as we have already discussed that junctions, at the junctions you have to decide about how much deduction has to be made in the center line so that it is not counted twice. So for that we have to be very careful for deciding type of junctions, number of junctions, which is very important for calculation as far as center line method is concerned. Let us suppose we have this type of rectangular room. This is its long wall, this is its short wall. We draw its center line. So see here, let us suppose here it is a partition wall in between here. So see here how what we this central, this is junction. So you can see here at the junction of the middle wall the head portion will be considered twice. So if you calculate length of the on this side, so you will be taking this junction, it will be head portion will be considered twice while calculating the center line length. So once while calculating the longer side, and while calculating the second times when while calculating the shorter wall length. So see here, if you have to calculate longer walls, this length and this length at the junction, what will happen, you will be you calculating or adding this junction twice. So for this you we need hash portion needs to be deducted during the calculation of correct length, and it is equals to the half the thickness of the wall. So how it is calculated we will be uh, discussing in the coming slides. See here, let us suppose how to find junctions and net center line length. So first of all you have to decide about the type and number of junctions. So this type of junction is called T junction. see here we have a room on this room on which a partition wall is provided, so it will be dividing the room into two parts. So at this type of junction is called T junction, where T is formed. This type of junction is called cross junction. So we are having this T junction 2, 3 and 4. These four are T junctions, and this is cross junction. So we do not need to take into consideration these corner junctions. These are corner junctions. These are not to be taken into consideration while calculating the net center line length. So you only have to check about the number of T junctions and number of cross junctions. So here in this figure there are four number of T junctions, 1, 2, 3 and 4, and one it is cross junctions. So let us suppose the total center line length is L1 and B is the width of the wall. Find the number of T junctions. Let us suppose number of T junctions are 1 and number of cross junctions are 2. Then the net center line length will be L1 total length which you calculate minus half the width. For T junction you will be deducting half the width of the wall. For each junction you will be deducting half the width of the wall. So for one junction it is 1 by 2 into B1, and for N1 junctions it will be half into B into N1, and for the cross junctions you will be having full width of the B into N2. So in this way you will be calculating the width of the uh, center line length of the wall. So now we will discuss how the center line length and net center line length is calculated when all the walls are of equal width. Let us suppose all the walls are of 300 millimeter thick. Let us suppose the outer dimensions of this longer side, along the longer side the length is 8908 millimeter, and the shorter side is 7900 millimeter. So along the longer side we are having three walls, 1, 2 and 3. Along the shorter side we are having 1, 2 and 3 walls. Now see here there are four number of T junctions, 1, 2, 3 and 4. These are the T junctions, and there is one cross junctions. So for T junctions you have to deduct half the thickness, and for cross junction you have to deduct one thickness for each cross junction, as we have already discussed. So center line length will be 7900 minus 300, 150 on this side and 150 on this side. The center line length will be 7600 for the shorter wall, and similarly for the longer wall center line length 8900 minus 150 minus 150, it will be 8600. So total center line length will be 3 into 1, 2 and 3 into 7600 plus 3 into 8600. Total center line length will be 48600, means 4.86 meter. Number of T junctions are C 1, 2, 3 and 4. And number of cross junction is 1. So you know for the cross junction you have to deduct half into 300 into 4, and for the cross junction you have to deduct full width. So 48600 minus half into 300 into 4 minus 300 into 1, 47700 means 4.77 meter. So in this way you can calculate the net center line length of the wall when all the walls are of equal width. Now we will be taking a real world example. You are having a building. See here, this is a building which whose plan is provided to you. We are having one room and having size of 3000 by 3000 millimeter, and another room having a size of 4000 by 305 3500 millimeter. Lobby with 7800 by 4000 millimeter, with passage 2200 millimeter wide, and with WC and bath the size is given to you. Every size is given in millimeter. So what you have to do, first of all you have to draw the center line of each and every wall, and name it at the junctions point. So as the rear wall, we name it as 1 2 3 4. We provide a numeric at the junction point 1 2 3 4. This wall has 5 6. This wall has 7 8 9 10. This wall has 11 12 13 14. This wall has 15 16, and this is as 17 and 18. So from the thickness of the walls, you can see that these are the partition walls and others are main walls. So see here, first of all we will be calculating the thickness size of main walls. See here, this wall 1 2 3 4, then 7 8 9 10, and 11 12 13 14. You have to find the length. So see here, you are having wall 3 into 0.15 on this side, plus point, then 3 meter this room, plus point 1 this partition wall, and then point 0.1 this partition wall, then 2.2 this distance, then point 0.1 and point 0.1, and then 2.2, and then 0.15 this thickness, half the thickness of this wall. So total length comes out to be 24.3 meter. Then for 17 and 18, this wall, this length will be 4 meter plus 0.15 plus 0.15, 4.3 meter. So no junction is there. See here. So similarly for 15 and 16, so length is 2.5 plus 0.15 on this side and 0.15 on this side, 2.8 meter. Similarly for the vertical walls, wall number 1 7 11 and 17, you can calculate 0.15 plus this length as 3 meter, then 0.15 this length as 4 meter, then 0.15 plus 3.15 plus 0.15. So this length is 11.4 meter. Similarly, you can calculate the length of center line length of 4, 6, 10 and 14. And similarly, you can calculate the length of partition walls, which is 2 and 8 and 3 and 9, and so length will be 2 walls 3 meter length plus 0.15 on this side plus 0.15 on this side, 6.6 meter. And horizontal partition walls is 5 and 6.1 on this side, 2.2 meter on this side, and 0.15 on this side, 2.45. So total center line length comes 9.05 for partition walls, and for the main walls the total length comes out to be 57 meter. So now we will be deciding about the number of junctions. See here, we are having 1 2 3 4 5 and 6. So at number main to main wall T junctions are 7 number, 10 number, 11, 12, 13 and 15. These are 6 number of T junctions. Okay, these are main to main wall. Okay, then main to partition wall, main to part, this is main wall, main to partition walls 2 8 3 9 and 6. These are 5 T junctions which are main to partition walls, 5 numbers. Then partition to partition wall, only one junction, number 5. Okay, this one junction is partition to partition wall. So how the center line length will be calculated? See here. So this is the cross section of the wall. So here in this case we will be doing calculation for DPC level only. So width of the foundation at the bottom is 900 and PCC width depth thickness is 200 millimeter. First step is 600 millimeter, 300 millimeter height. Then up to ground level, this width the depth is 450 millimeter, 500 millimeter width, and this is 400 millimeter by 300 millimeter up to from ground level to plinth level. This is the cross section of main wall, and this is the cross section of partition wall with 700 millimeter width at the bottom, 450 millimeter up to ground level, 200 millimeter is thickness of the PCC, 600 millimeter thickness, and then 400 millimeter, and then 200 millimeter is thickness of the wall, and this is 300 millimeter thickness of the wall. So see here, you have to calculate the net center line length. Main to main wall junctions are 6, main to partition wall junctions are 5, partition to partition wall junctions are 1. So what will be the total length? See here, 57 meter, half the number of junctions, T junctions, 0.5 into thickness of the wall as 300 millimeter, and then for 30 meter walls, the 30 centimeter wall total length is 57. From the 57 you have to deduct zero point 0.5 of the thickness of the thickness at wall at this level is 900 millimeter, means zero point 0.9, zero point 0.5 into 6 number of main to main wall junctions. See here, zero point 0.5 into 6 into 0.9. So B9, B6 is we have done the calculations in the Excel format. So B6 is the this cell. So we have written here B6. B6 means this B6. So number of junctions are 6.5 into 6 into 0.9. 0.9 is the width of the wall at foundation level. So its length comes out to be 54.3 meters, width you know is zero point 0.9, and height is 0.95. Total depth you calculate it, total 450 into 300 into plus 200. So it is 0.95. So total excavation will be 0.95. Similarly for 20 centimeter walls, so total length we have calculated is 9.05 meter. This length is 9.05 meter. So we have to deduct the number of junctions. So number of junctions, zero point 0.5 into number of junctions with the main wall partition is 5.5, and number of junctions with the partition wall is 1. So 0 0.5 into 1 into 0 0.7, 0 0.5 into 5 into 0 0.7. So it comes out to be 6.45 meter. 0 0.7 meter is the width and 0.65 meter is the height. So you calculate the quantity in this way. For DPC, PCC in foundation, same length will be there, 54.3 and 7.4. 7.2 to 20 centimeter walls. So it will remain the same. For 20 centimeter wall, you will be calculating 9.05 into 0.5 into number of junctions 5 into zero point 0.6. So here at this level the thickness of the main wall is, see here, is 600 millimeters. So here at this level the thickness of the wall was zero point 0.9 at the bottom level. At this level it is zero point 0.6 meters, so you will be deducting zero point 0.6. And similarly at minus zero point 0.5 into b8 into this level is zero point 0.7. So this, in this way you will be calculating the length of 20 centimeter wall, which will be changed. It will be 7.2, width is zero point 0.7, and zero point 0.2 is height of the wall, this PCC. So similarly you can calculate the foundation and plinth in the foundation for first step, for second step. First 30 centimeter wall, first step is 600 millimeter, second 0.6, second step is zero point 0.5, and third step is zero point 0.4. And height, you know, it is given to you, you can do its calculation easily, as you know how to calculate the center line length. So in this way you can calculate the center line length of the walls, and then other things are given to you. So this is all in this video. Have a nice day. Thank you very much.